Now let's say the local zoo authority comes to you with the following set of requirements. Perhaps they want to computerize their zoo information. So what they're saying is, we have different categories of animals: reptiles, mammals, birds, fish, and each animal has a strict dietary schedule of food items. Our staff is supposed to feed them as per this schedule. Each food item has a specific supplier. We maintain a list of suppliers for these food items. We have an in-house team of vets. However, in emergencies and complications, when our in-house vets can't handle the situation, we do call external vets. So they want to maintain vet information too. We need to maintain a record of emergencies and the amount spent on it, external vet fees, his flying bill, cost spent on his stay, etc. Each cage houses a particular animal, and the cages are named something like this: A3, B5 and all. So we're going to follow a 4-step procedure for designing our database. So over here, the first stage is finding out all the entities. Entities basically appear as nouns, or basically entities anything about which information needs to be stored. So let's underline our entities. So categories can be an entity, animals can be an entity, food item can be an entity, staff can be an entity. Maybe they want to store the staff information, maybe they want to store the food information, maybe we want to show information animals and their categories. They may want to store information about the suppliers, they may want to store the information about the vets, they may want to store the emergencies. Then they have external vets as well as internal vets, in-house vets. They want to name the cages also. Okay. So this is the output of stage 1, in which we found out all the entities. The next stage is finding the relationship between entities. In this, we'll take a pair of entities and try to find the relationship between them. So let's model the relationship between cage and animal. The procedure is, you take one entity from one side and ask yourself how many entities of the other side it's related to. For example, a cage has how many animals? A cage only has one kind of animal. So mark the answer or jot the answer on the opposite side. So we'll mark 1 over here. And the same procedure will follow on this side. One animal belongs to how many cages? One animal belongs to one cage. So we'll mark 1 over here. So this is basically a one-to-one relationship. So let's model the relationship between animal and food item. So we are going to follow the same procedure of taking one entity and asking ourselves how many entities of the other side it's related to. So over here, one animal can consume how many food items? So one animal can consume many food items. For example, let's say they give different types of meats to an animal like lion. So an animal can consume many types of meats. So one animal can consume many food items. So we write n over here. And one food item can be consumed by how many animals? One food item, for example meat, can be consumed by different animals. For example, they are giving the same meat to lions and cheetahs. So one food item can be consumed by many animals. So we write n on the opposite side. So this is basically a many-to-many relationship. So let's model the relationship between food item and supplier. Now one food item is supplied by how many suppliers? So if you see the requirements document over here, it says that each food item has a specific supplier. So over here we'll mark 1 on this side, because each food item, one food item, is supplied by only a single supplier, and one supplier perhaps may be supplying many food items. So we'll mark n over here. So this is basically a one-to-many relationship. Let's map the relationship between animal and category. So one animal is in how many categories, or one animal belongs to how many categories? One animal can belong to just one category. Category being mammals, birds, reptiles, something like that. So one animal can belong to one category, because we have to jot the answer on the other side. Similarly, in this way, one category has how many animals? So one category has many kinds of animals. So jot the answer on the other side. So one category has many animals. So it's a one-to-many relationship. So this was the output of step 1, in which we found out the entities, and over here is the output of step 2, in which we marked all the relationship. We marked one-to-one relationship, many-to-many relationship, and one-to-many relationships. Also, there is a generalization relationship between vet, in-house vet, and external vet. The common attributes will store in the vet table, and the specific attributes will store in the child tables over here. And staff and emergency are sort of dangling tables, because they are not related to any other tables. Now, after modeling the relationship, the third step is assigning attributes and the keys. So I've put some attributes in all the entities, and I've assigned primary keys for each entity. So over here, the primary key is denoted using PK stereotype, and there is a specific convention followed for naming the primary key. It's entity name underscore ID. And for the generalization relationship over here, the same primary key is used for the parent table as well as the child tables. So in the previous stage, we assigned attributes as well as primary key to all our entities. In this last step, we are going to map the relationships. So over here, for one-to-one mapping, we take the primary key of either side and put it on the other side as our foreign key. So over here, I taken the animal ID, which is the primary key of this side, and put it on the other side as the foreign key. So that's shown over here. Or we could have taken primary key from this side, that is cage ID, and put on this side as the foreign key, that is cage ID over here as foreign key. But let's now go for this, that is animal ID on this side. For mapping one-to-many relationships, you take the primary key of one side and put it on the many side as the foreign key. So we'll take the primary key of the one side, which is supply ID over here, and put it on the other side as foreign key. So compared to one-to-one relationship in which you took a primary key of either side and put in the other side as the foreign key, for one-to-many relationship you would compulsorily take the primary key of one side and put it on the other side. Now let's account for many-to-many relationship. There is a many-to-many relationship between animal and food item. For mapping many-to-many relationships, we have to create a new table comprising of the primary keys of the related table. So over here, the compound primary key is animal ID plus food item ID, and there is a convention followed for naming this table, which is the combination of the names of the related table. So many-to-many mappings requires little bit more effort than previous relationships because we have to create a new table. So let's summarize the 4 steps. In the first step, we found out all the entities. In the second step, we marked the relationship between entities. We marked one-to-one, many-to-many, one-to-many relationship, as well as generalization relationship between vet and the child vets over here. And in the third stage, we assigned attributes and the primary key. So there are the attributes, and the primary key has primary key stereotype, and the primary key for generalization is the same primary key used for the child tables. And over here in the last stage, we introduce new attributes for mapping the relationships. For mapping one-to-one relationships, you take the primary key of either side and put it on the other side as the foreign key. Over here, we took the animal ID, which is the primary key of this side, and put it on this side as a foreign key. For mapping one-to-many relationships, you take the primary key of one side and put it on the n side as a foreign key. For mapping many-to-many relationship, you take the primary key of both sides and create a new table comprising of a compound primary key of these two tables, and the naming convention used is the combination of the table names. Also note that the primary key of the joining table also serves as a foreign key to its related table. So over here, animal ID also serves as foreign key for the animal ID primary key mentioned over here, and food item ID serves as a foreign key for the food item ID primary key mentioned over here. For generalization, the child table primary key also serves as a foreign key to the parent table primary key.